today in lesson I4, we're talking about equally likely and sample spaces. This is standard SPA. I can recognize that events are equally likely or not likely. I can create a sample space of all possible outcomes for a compound, even by using an organized list. I can use sample space to compare the number of favorable outcomes and the total number of outcomes and determine the probability of a compound event. So an outcome is the result of a single observation of an experiment. So when we're talking about one thing happening, we're talking about heads being when we flip a coin, that outcome, we have one outcome, heads or tails, on a coin. So two outcomes on our coin. A sample space of an experiment is the set of all possible outcomes for that experiment. So an outcome is the result of a single observation. So we know we have two, that's our sample space in a coin. The outcome would be when we flip it, we get heads, which would give us 1 out of 2 times that happens. So an outcome of an experiment that are equally likely to occur when the probability of the outcome is equal. So if we are filling in our notes, it says, suppose you have a bag of crayons and it has 10 green, 10 red, 10 yellow, 10 orange, and 10 purple. Complete the following statement. If one crayon is selected, the outcome is, and so here in our bag, so the outcome is, if we are looking at that, our outcome is going to be the color that's going to be chosen. So if it would be green, red, yellow, any of our colors, the sample space will be, when we are talking about that, that is going to be all the colors. That's the green, the red, the yellow, the orange, and purple. And if you need to pause this to write down those colors, please do so. Each color in this case is equally likely to be selected because, and if we think of this, each one has 10. They have an equal number in each one. Each color has the same chance of being chosen, because we have 10 green, 10 red, 10 yellow, 10 orange, and 10 purple. So if I say, what's the probability of choosing a green? We have 10 green out of our total of 50 that we are looking at. Okay? Again, if you need to pause it before you go on, please do so. So we are going to be taking a look at is our sample space. So what is a sample space as we are looking at this? That's the set of all possible outcomes for our experiment. For each of the following, we want to list the sample space. So if I roll a 4-sided dice and I have the numbers 1 to 4 on the faces, what are, if I was asking you to list the sample, so my sample would be listing the numbers on your paper. You should write down 1, 2, 3, 4. Okay, those are my outcomes. If I said selecting a word from the word mathematics, selecting a letter from the word mathematics. So we are going to write down the M, the A, the T, the H, the E. I'm not going to put T again. So I already put T once. I'm not going to write it again. Then I'm going to have the I and the C and the S. So if I'm looking at this one, M, A, T, H, E, I, I'm not writing the T, C, or S. That is my sample space. It then says, if I'm selecting a marble from a bag that has 50 black and 50 orange, what would my sample space be? My sample space is going to be black or orange. I want you to take a look at this spinner. As you look at this spinner, I want you to look at the sample, selecting a number that is even from 2 to 14. So if we are looking at this one, selecting a number that is even between 2 and 14. If I just gave you that and not looking at the spinner, you would tell me 2, 4, 6, 8, 10, 12, and 14. Now, this one says looking at this spinner. Okay, so when you are looking at the spinner, what is my, if we are going to give our sample space as I look at the spinner? My sample space as I look at the spinner would be 1, 2, 3, and 4. Okay. Now, they are not all equally likely, but that is my sample that I am looking at. Those are the letters or the numbers, if we think about those. So thinking about sample space, you're going to be asked to do this in your homework. You're going to be asked to list the sample space as you look at something, and then you're also going to be asked to do this next part, which is it equally likely? So equally likely. So one of the first questions says list your sample space in your homework, and then it says equally likely, which means each outcome is equal. For each of the following, decide if each of the outcomes is equally likely. Give your answers a reason. So if we are looking at rolling a 1 or 2 on a 6-sided dice, so rolling a 1 or a 2 on a 6-sided dice. Well, if I roll a 1, that's 1 out of 6, and if I roll a 2, that's going to be 1 out of 6. So are they equally likely? Yes. Each has the same chance of occurring. What would that chance be? 1 out of 6 for the 1, and for rolling a 2, it would also be a 1 out of 6. Selecting the word K from the word take. So if I'm selecting the K from the word take, is it A or K? Is it equally likely? Well, there's one A and there's one K. So if we are looking at that, yes, each has the same chance. Again, what would it be for an A? Drawing an A would be 1 out of 4. Drawing a K, again, would be 1 out of 4. Selecting a black or orange marble in a bag with 50 black and 45 orange. So if we look at that one, do we think that will be equally likely? Just because the numbers are not the same, we're tending to think no. Black has a greater chance. And if we were looking at that, we would look at black as being 50 out of 95, whereas our orange would be 45 out of 95. And again, you could simplify those fractions. If we are looking at this next one, selecting a 4 or an 8 from the even numbers 2 to 14, do we think that is equally likely? And in this case, we would think, yes, it has the same chance because, again, you're looking at 2, 4, 6, 8, 10, 12, and 14. This is 7 outcomes. And getting a 4, if we're thinking of that, the 4 would be once out of 7. Choosing an 8 would be 1 out of 7. If we look at the spinner, it says, what do we think? Do we think it's equally likely of landing on a 1 or a 3? Okay? And as you look at the areas of those, that's kind of what helps us decide if it's equally likely. The 1 area is much larger, so it has a greater chance of occurring. So if you've ever watched like Wheel of Fortune, when they have all of those sections divided up, this is kind of that equally likely chance. Again, if you need to pause the video to write any of this down, make sure you do so. Here we are going to be looking at, you're going to be playing a game. And what I want for you to do, as you play the game below, it requires the spinner, you to spin the spinner twice. For example, one outcome could be yellow on the first and red on the second. And we're going to list all possible outcomes of our 2 spins. So what I want you to be thinking about is this is going to be the first spin. And what are our outcomes? And this is going to be the second spin. So as we are taking a look at those 2, on the first spin I could get, and if I want to just put them, if I get yellow, I could get yellow and red. I could get yellow and yellow. I could get yellow and green, and I could get yellow and blue. On the first spin, if I start with a red, I could get red and red. I could get red with yellow. I could get red with blue. I could get red with green. What I would like for you to do is to list the rest of your outcomes. You should have another one that now starts with green, and then you should have how many of those for green? Should be 4. And then you should have your blue. So list all of those and tell me how many possible outcomes we should have. The next question over, so you're going to pause the video and finish that. The next question says, list in the sample space the chance of the experiment of flipping a coin twice. So this will be the first flip. and this will be the second flip. I want you to think, how many possible outcomes are there? Now in this one, what you should have seen when you listed all of those is that you had 16 possible. If we are looking at the first spin, you had, from our first spin, you had 4 possibilities, times on the second spin, you had another 4 possibilities, and 4 times 4 is equal to 16. On our coin flip, if we are thinking, we can have head with tails and head with rolling a head. We can have tails with tails and tails with heads. So we should have 4 possible outcomes. And if we are looking at this, the key thing to remember is that as you do this, the possibilities for the first one times the possibility for the second one give me all of my total outcomes. Now, tomorrow we're going to be looking at another way of doing this with probability, which is listing them in tables and tree diagrams. But for today, you are now going to be doing this homework. So when you look at equally likely and sample spaces, think back. Consider the experiment of selecting the word algebra. What is your sample space? So again, that first part in our homework in our notes, sample space. It says list the probability of the outcome in the sample space. So the probability of each outcome. So that means the probability of an A. What do we think that probability is? The probability of getting an L. The probability of getting a G. Okay, so please list all of those. And you're going to kind of do the same thing. Then it says, is each one equally likely? Think about how many here you have as you're looking at those. Then as you look at question 2, as you are looking at that one, they are simply asking us to take a look. And as we are doing that, make these just a little larger, right? So it says you're playing with these spinners, list the sample space, possible outcomes of the game, what's the probability. So as you are doing this assignment, you are just doing lesson I-4. It is the front and back of this sheet. And then we will have that for when you come back to class. When you finish this homework, you can also go on to Dreambox.